Folks, these are the formulas we're going to use throughout this video. On the left, we have the definite integral going from a to b. On the right, we have the Riemann summation. And some folks use I as in India instead of k. And finally, we have the formula for delta x, which is going to be b minus a over n. And we're going to be using these formulas to go back and forth between the definite integral and the Riemann sum notation. Now, if you watch my previous video on this topic, what we're going to do is we're going to replace this x with what I call x on steroids. And we're going to get this information. We're going to get the information on the steroids from the a and the b value. We're going to create our delta x, and that is how we are going to formulate the Riemann summation. In our first expression, we are given this Riemann summation and asked to go to the definite integral, and throughout we're going to be referring to the expression on the upper right corner of the screen. Okay, so the first thing we need when we look at this is we recognize, folks, that these are the steroids, and they are within that function quantity squared. So that tells us in our integral we're going to have x squared. The plus 1 does not change. As you move from this definite integral to that Riemann summation, all we did is replace that x. When we went to the Riemann sum, we replaced it with steroids. You could see the steroids are to the second power. Okay, the next thing we do is we look at the original Riemann sum, and we notice that there's a delta x out here matching the pattern of the expression on the right. So what do we have so far? We have the integral of x squared plus 1, and what we're trying now to find are these a and b values. We're going to use that delta x because we know that delta x, which in this problem is 2 over n, equals our b minus a over n. So if we pattern match the numerators, we know that b minus a in this particular problem is going to equal 2. So we need the a and the b values. Folks, they gave us the a value. Here it is right over here. If we open up this expression that I call steroids, this is what they gave us. We know that 2 over n is our delta x value right here. So this is clearly delta x times k, or otherwise known as k times delta x. So that must be our a value. So if we know that a equals 1 and that b minus a equals 2, we know our b value is 3. Therefore, our final definite integral is going to run from a to b, a being equal to 1 and b equal to 3, and this is going to be times dx. In this Riemann sum that we are given, they are using the I notation rather than the k. Remember, k and I are used interchangeably in this fashion. Okay, so here we have a Riemann sum, and we're trying to get to the integral. So folks, here's our function right there. So that's going to be in the definite integral. When we went from the definite integral to this Riemann summation, this x was replaced by those steroids. So these are our steroids. This is what matches to a plus k delta x. So what do we have here? We have a plus I delta x. So that means our delta x equals pi over n. And look, it matches because that pi over n is being multiplied by the function. Oftentimes we'll see the dx after the function. Here they presented it in front. But the key is to recognize, or at least in this case, confirm that we have the correct delta x. So now we know that our a value is 0. And we know our delta x equals pi over n. We're going to use this formula, b minus a over n equals pi over n. We know that our a value is 0. We can go ahead and put that in. The question is, what is that b value? So we know b minus 0 is going to give us pi. Again, we're pattern matching the numerators. Therefore, our b value must be pi. So we're going to replace this letter b with pi. And folks, this is our definite integral right here. Sorry, it's a little messy. In the next example, we recognize these to be the steroids right there. So when we move to our definite integral, our function is going to look like that. These are the steroids that, when you move from the definite integral to the Riemann sum, you replace that x with the steroids. Okay, so going back to the steroids, we recognize that it fits the pattern of a plus I delta x. So we identify our delta x as right here being multiplied by I, 4 over n. So our delta x is going to equal 4 over n. And folks, we can confirm that by noticing that that 4 over n is on the outside of the function, just like it is over here on the upper right. Okay, once we have our delta x, we now notice, if we pattern match, that that is our a value. So this integral is going to start at a and go to some b. To get the b, we're going to use that formula we've been using thus far in the video, where b minus a over n equals delta x. In this case, our delta x is 4. Therefore, we're going to have b minus a equals 4. b minus 1, which we already know is 4, and therefore our b value is going to be 5, and that is our definite integral right here. In our last example, we found that this Riemann sum notation resulted in the definite integral from 1 to 5 of the square root of x. However, folks, I want you to notice that these are equivalent expressions, this one in the light blue and the yellow. So look what we did. We shifted the integral, the intervals from a to b, 1 to the left. So 1 was shifted to 0, 5 was shifted to 4, and we adjusted the function. This is indicative of a transformation of a graph 1 unit to the left. And when we did that, you could see that these two areas are equivalent. Recall that if a function is positive and continuous, we are able to say that the definite integral represents the area under the curve. That is not true if a portion of the graph is negative. For example, on a total tributary here, if we had this graph, y equals 2x, and that's going to look something like that with a slope of 2, we cannot say that the area under this curve from, let's call this -5 to +3, we cannot say that this definite integral represents the area under that curve, y equals 2x, because when you sum up the integral from -5 to 0 and then from 0 to +3, overall your definite integral is going to be negative. And according to the strict definition of area, if that's negative, this does not represent the area under the curve, and you could see portions of f of x in this interval from -5 to +3 is indeed showing a y value that is negative. In our next example, we are given this Riemann summation that involves E. And if we focus right here, this looks like the steroids. So what we're going to have here, folks, is a definite integral that involves e to the x, where when we went to the Riemann sum, the x was replaced with these steroids. Okay, if we pattern match 3 plus I over n over here, we can clearly see that our delta x is 1 over n, and that is confirmed when we see the 1 over n out here. Now, the next task is to find the a and the b. Well, they give us the a. The a is right here. It matches with the 3, so let's take that a out and replace it with 3. And then we recall that b minus a over n is going to equal delta x, and in this problem, our delta x equals 1 over n. As we've been doing the entire video, we're going to pattern match the numerators. We know our a value is 3, therefore our b value has to be positive 4. So folks, this is the definite integral that matches that Riemann summation. Now, folks, we can adjust the intervals on this definite integral. And when we do that, we just have to change the integrand accordingly. So let's say we wanted to go from 0 to 1. These have to stay one apart like they were originally. So in essence, we've shifted from 3 and we went 3 units to the left, 0 to 0. Therefore, we have to shift our graph 3 units to the left. And the way we transform a graph to the left is we would do f of x plus 3, and we would have this integral here. So these definite integrals would result in the same evaluation. Next, we are given this Riemann summation and asked to go to the definite integral. Folks, we focus right in on here, and this looks to me like these are the steroids. So our definite integral is simply going to have x to the second power. That's our function here. We're going to identify this as our delta x. It's outside. And to confirm that, if we expand this, you could see here's our delta x in here being multiplied by k. So we have an a value of 4, and we have a delta x value here of 6 over n. We're going to use that to declare the intervals on the definite integral. So right away we know our a value is 4. The only question is, what is the b value? If we do b minus a over n and we set that equal to 6 over n, we know that b minus a is going to equal 6 because the numerators have to match. B minus 4 equals 6. Therefore, b is going to equal to 10. So this is our definite integral that would match this Riemann summation. Now, folks, suppose we wanted to adjust the interval on this definite integral. For example, as is often the case, we want to start at 0. So if we change this to going from 0 to 6, remember these have to remain 6 apart like they were originally, then we would simply have to shift our original function 4 units to the left because we shifted this starting interval 4 units to the left. We went from 4 to 0. That's 4 units to the left. We have to shift our function accordingly, and this is the definite integral that would match. Now, for fun, let's go now and take this definite integral and recreate the Riemann summation and see if we get what matches up here in green, which was the original. So our Riemann summation, moving from this definite integral now with intervals going from 0 to 6, is going to look like as follows. So the beginning is always the same. Now we're going to have x on steroids. So instead of x, we're going to replace x on steroids here. All right. So our delta x is going to be b minus a over n. Okay. Our a is going to be 0. A is going to equal 0. That's our starting part of the interval. And delta x is going to equal b minus a over n. B is 6, A is 0, therefore our delta x is going to remain at 6 over n. So we're going to put steroids in here. This original plus 4 is going to stay as is. We're not going to touch that. We're going to take that x and replace it with A, which is 0, plus k delta x. And that would be 6 over n times k. And then our delta x would appear on the outside as it did before. And when we go ahead and simplify that, we're going to have this will simplify to 4 plus 6 over n times k squared with 6 over n out front, and that is exactly what we had at the origin of this segment there in green. Next, we are given this definite integral and asked to go to this Riemann summation. So right here, folks, we're going to replace this x with x on steroids. Everything else is going to stay the same. So we're going to have the 2 here And instead of x, we're going to do f of x on steroids. So first we need to do is identify the a value. The a value is given to us right there as 4 plus, and then we're going to do I times delta x. So we have to find delta x. What is delta x? Delta x is b minus a over n. b minus a over n equals 5 over n. So therefore, we're going to multiply here by delta x on the outside. That matches this part of our expression over here. This is our delta x right here. And then we're going to take this delta x and we're going to replace that with 5 over n. And folks, this is the Riemann summation that represents that definite integral. Let me just clean that up a little bit, and that is the end of this problem. Next, we are given this definite integral and asked to go to the Riemann sum. First thing we're going to do is we're going to replace this x with x on steroids. So we're going to have tangent of x on steroids, and the whole thing is going to be multiplied by delta x. That's our game plan. Okay, so our steroids are going to consist, as shown here, of a plus k delta x. Our a value they give us as 0. Okay, here's our k, and now we have to figure out what delta x is. So the delta x is going to be b minus a over n. So pi over 4 minus 0 divided by n is going to be pi over 4 divided by n. If we multiply top and bottom by 4, we're going to get pi over 4n as our delta x. We're going to come along here and take away this delta x and replace it with pi over 4n. And we're going to add pi over 4n here. And if we want, we can go ahead and eliminate that 0. And folks, this is our final Riemann sum as shown. In our next example, we're asked to go from this Riemann sum to a definite integral. So we know we're going to have sine involved, and we believe that this is where the x would be, and it has been replaced with x on steroids. So now we have to find the a and the b value. Well, it appears here that the a value is going to be pi over 4. Now, when we get to the b value, we're going to use the formula that b minus a over n is going to equal delta x. Now, the question here in this Riemann sum is, what is the delta x? You could see over here the delta x appears both outside of the function as well as being multiplied by k or I. So the question in this problem is, what's the real delta x? Is it this pi over n, or is it pi over 2n? So I think what clears up the mystery a little bit is that we can rewrite this outside expression as 1/2 times pi over n. And when you do that, then it makes it clear that the delta x is pi over n, and that this 1/2 can be placed in front of the sine of x. Okay, so now we're going to have b minus a equals delta x, where our delta x equals pi over n. So that means if we match the numerators, we're going to have b minus a equals pi. We know that a equals pi over 4, so we ask ourselves, what would b have to be? If we subtract pi over 4, we get 4 pi over 4, which is otherwise known as pi. So b has to be 5 pi over 4. And that is your final definite integral. In this next example, we're asked to write this Riemann sum as a definite integral. But here, we don't have the summation symbol. Here, it looks like k has actually been installed here. So here, in this first term, we're going to have k equals 1. Here, we're going to have k equals 2, etc. So if we replace this 1 with a k, we see that these are our steroids right here. And that would make that 1 over n our delta x. And that matches the delta x on the outside. So as we put our definite integral together, we can call that 1 as our a value. So that's going to be 1. We're going to go to b, and it looks like we're going to have 1 over x. And when we went from the integral to the Riemann sum, this became the x on steroids. So next we just need to figure out that b. Okay, so we have delta x equals 1 over n. Let's write that over here. Delta x equals 1 over n. And we know that b minus a over n equals our delta x. We know our a value, so we're going to pattern match these numerators, and we're going to say that the b value minus 1 is going to equal 1. That would mean our b value has to be 2. So folks, this becomes our definite integral. Next, we have the Riemann summation shown here. So if we move to our definite integral, it looks like we have a function of the square root going on with x under the radical. And then as we move from the integral to the Riemann sum, this is our steroids underneath. Now it appears to me that here our k value starts off as 1. And so we have delta x times the k value of 1. So here, if we have delta x of 5 over n times a k value of 2, that yields the 10 over n. So I believe here our delta x is going to equal 5 over n, and our a value is going to be 4. So let's put 4 in the a value, and in order to get the b, we're going to do b minus a over n, and we're going to say our delta x is 5 over n. Therefore, if we match the numerators, we're going to have b minus 4 equals 5, and therefore b has to equal 9. So our final integral is going to be the square root of x with intervals from 4 to 9.